All right, class, my really long video of what it simply meant to find a definite integral being gone, let's just go and practice. Okay, so to find the area trapped under a function between two values simply means to find the definite integral from a to b, so from 2 to 4, right? Those are called, again, the limits of integration of this function. Okay? Now, I just want to give you still an idea of what this area might look like. We won't be able to find it, which is also why I want to show it to you. If you guys remember, what is the shape of this function here? This function here is a parabola, right? So you're welcome to put in your graphing calculators and such. I'm going to plug in a value of 0. If I plug in 0 for x, I'm going to get a 5, yes. It turns out the vertex is somewhere to the left of it. So if you put it in your graphing calculator, you will see that it's a parabola that stays above the x-axis. Okay, so what we want is we want to find the area between 2 and 4 under this curve. So this would be it. The area from 2 to 4 under this function f of x. Now the thing is, this looks almost like a trapezoid. This could be almost linear, except for it's not. It's a little curvy. I could try and approximate it, right? That's the height is 2, this height from this base and this base, plug in a 2 into this function, plug in a 4 into this function. We could try and see how close we get if we pretend that's a trapezoid, but it's not. So the point is that what we need to do is, since this isn't a regular shape, because this isn't a straight line, it might look like it, but it's curvy, okay? The only way to really find this exactly, and not by approximating, is to find this definite integral. So the rule says that you're going to simply find the antiderivative. So what's the antiderivative? Is 3 x to the third over 3 plus 2 x to the second over 2 plus 5x. And again, remember, plus some constant k, except for you don't need to worry about that constant when you find definite integrals. Why? Because we're going to throw in some values in it. Okay, I'm going to simplify this a bit some more. It just makes computation easier. So that's really an x cubed plus an x squared plus 5x. And what does it mean to put in these two limits of integration? Means plug in first the 4 minus, so it's all the way from here minus here. So you first are going to plug in the 4. Remember, it's an area also, and areas always have to come out to be positive. So to make sure you get a positive answer, you always want to substitute or subtract from the larger value the smaller value. Okay, so there's that. So what are we going to get? Well, that's a 64 plus 16 plus 20 minus that's an 8 plus 4 plus 10. So that's 70, 80, that's 100. Minus that's 1222. So that's going to equal to a 78 square units. Okay, so put that in your calculator and you're good to go. Okay, so one more time, because k would cancel out. What do I mean by k would cancel out? If I'd put a plus k here, yes, I'd have a plus k and a plus k, which will be a plus k, and then a minus k, right? Once I distribute in the minus, and they would cancel out every single time. So because k would cancel out every time, we evaluate a definite integral, okay? We don't need, we don't need to write them, to write the k. And what's a definite integral versus a non-definite integral, also called an indefinite integral? It has the a and the b, right? So it has those limits of integration. All right, so let's move on, okay? Now, as I said, you're welcome to find and try and find the area really quick and see if we get close to 78. I'm going to leave that up to you. As for fun, let's see what happens. All right, so the point is that we will have to find definite integrals in the next sections for all sorts of reasons, right? We are going to see what applications we find for definite integrals. So what we want to do is just practice on evaluating more definite integrals, right? So for whatever reason, maybe it's area reasons, maybe it's accumulated value in an account, maybe it's distance traveled over a period of time, or whatever else we might see is going to come our way. Total cost, right? Or total profit made from selling between 100 and 200 units or something like that. Okay, so here it is. It's a definite integral because you see the limits of integration. And it also says evaluate. By the way, this is going to be one of our differences. When we find an indefinite integral, we find a family of functions. Yes? The answers were always about some x. So we found a function, right, for an answer in 5.1 and 5.2. Now, these last few questions, what was our answer? Our answer was a value, 78 square units, 20 square units. So we get a value for an answer every time, a number, right? This is why the instructions will say evaluate. Good. All right, so let's see. How do we evaluate this? So first things first, look at the function inside and find its antiderivative. So the antiderivative of this is, remember, keep the coefficient of 5. The antiderivative of an e is itself, yes? But you must divide by whatever coefficient x would have, which is a 2. Now, it's a definite integral, so what we do now is we throw the limits of integration. So this number, or this expression, between 0 and 1. So what we do is we plug in a 1, minus, we're plugging in a 0. That's it. So that's the extra step. Evaluate that antiderivative at the top limit of integration minus evaluate that antiderivative at the lower limit of integration. So what do we get? 5e to the second divided by 2, whatever that is, minus, again, the e to the 0 is a 1, so 5 halves. Now, you could perfectly leave it like this. It's an exact value. It's really not a big deal. If you want to put it in your calculator, you will find the approximation for this is about 15.97. Now, as you see, I am not writing square units or anything because I am not asked to find the area. Who knows what this antiderivative was being, what this definite integral, I should say, was being used for. So there's no reason to write square units unless we're asked to find an area. Okay, well, this looks fancy. What should I be doing with this function? If I want to find the antiderivative of it, I better fix it. So I'm just rewriting these values. That's a 5 over. This x, again, I'm going to bring it to the top by putting a negative exponent to it. And how do I rewrite the cube root of x to the 4th? It's an x to the 4 divided by 3. So remember, the index of the radical always becomes your denominator, yes? The exponent is your numerator. Plus 2, this x also has to come to the top. That's an x to the negative 3, right? That's it. Plus 5 times, should I rewrite this 1 over x as an x to the negative 1? Or do you guys recognize maybe a special case? So sure enough, the x to the negative 1, you can write it as an x to the negative 1, but you won't be able to use the power rule. So again, we went over it in the last section, and I said you will make that mistake to think it's an x to the negative 1, and then you end up using the power rule, and you end up with a 0 in the denominator. And hopefully by then you'll get the clue that, oops, I wasn't supposed to do that for this one. So sure enough, this is our special case. Yes. Okay, so let's find the antiderivative. Keep the 5, x to the, what am I doing? I'm adding another 1 to that exponent. So here I'll write it out for you. Negative 4/3 plus 1 divided by the same exponent plus 2 times x to the, add a 1 to the negative 3 divided by that same exponent, plus 5, what's the antiderivative of 1 over x? Well, that's a special case. Then the antiderivative of 1 over x is ln of x. Okay, so I'm already done. I found my antiderivative. Now I have to plug in 1 and plug in 5. Now, sure enough, you're thinking, ooh, maybe I don't want to plug in these values just yet. I would like to simplify this first, right, before I throw in more, and you'd be completely correct. So let's try and fix this, and I don't want to go through. Here it is. What is negative 4/3 plus 1? Negative 4/3 plus 1 is negative 1/3, yes? So that's exactly what this here adds up to, a negative 1/3. What happens when you divide by a negative 1/3? You multiply by its reciprocal, right? Which is negative 3 over 1. So what I'm doing is, and you're welcome to put this in your calculator, and your calculator will tell you that 5 divided by negative 1/3 is equal to negative 15. Okay, let's see about this exponent, or yeah, this exponent here. Negative 3 plus 1 is negative 2. So what is 2 divided by negative 2? That's just a negative 1, right? And then that 5 ln x. Okay, so that's much better now. Plug in a 5 and then plug in a 1. All right, so I'm getting, and again, this is going to be something you put in your calculator. That's negative 15, and you don't even have to fix it because your calculator knows what 5 to the negative 1/3 is, minus 5 to the negative 2. So you don't need to fix up anything. Just put all of this as it is. Make sure you type it nicely in your calculator and you don't mess up on putting numbers in your calculator. Minus the same thing. Plug in now a 1. So 1 to the negative 1/3 minus 1 to the negative 2 plus 5 times ln of 1. By the way, the absolute value of 1 is 1. The absolute value of 5 is 5. That might be easy. That's a 0. That's a negative 1. Negative 15 minus 1. That's a negative 16 from the second parentheses. I could tell you that without a calculator, but that's not a big deal, because this has to come out of a calculator anyhow. And if you put that in, That's actually a decimal, so that's a negative 0.764. Minus minus turns into a plus, by the way, right? So it's going to be 16 minus 0.764, which is going to be about 15.236. Okay, so your calculator will definitely be your friend in these problems. All right, this one's much easier. And that's a good problem to look at. Okay, so here it is. The integral from -2 to 2 of 1 over x dx. This is easy because there's nothing to fix, no many problems. What's the antiderivative of 1 over x again? It's ln of x, right? Between -2 and 2. And that's exactly what I said is important, that you plug. It is very important that you put those absolute values, because in ln of -2, your calculator wouldn't know what to tell you about that. So that's really absolute value of 2 is 2. Absolute value of -2 is also 2. You don't really even need a calculator to know that this answer comes up to be a 0. Okay, so it's just that easy. So I do want to show you why that comes up to be a 0. You might remember what the graph of 1 over x looks like. 1 over x is the reciprocal function. And the 1 over x very much looks like this. Here, I'll draw it in red. Make sure that it's quite even. What do I mean by that is this looks exactly the same, right? And then between -2 and +2, what's the area under the curve between -2 and +2? As a matter of fact, that's an infinite area, because this graph will never ever touch the y-axis. It'll get closer and closer, but it won't even touch it. And then what's the area here? It's the same thing, right? And so remember, what really is happening is that I'm getting the area from here to here minus the area from here to here. They are symmetrical. They look exactly the same. So this little piece minus this positive piece, I should say, minus this positive piece from here, they add up to 0. So I have the same amount under the graph on the positive side as I have on the negative side. So that's a positive area. That's going to be minus this area, right? So it's a negative area per se. So this area comes out negative. This area comes out positive. When I add the two, they cancel each other out, right? So that's why I'm getting a 0. That's a positive quantity. Under the x-axis will be a negative quantity, okay? All right. So let's see. Let's put all this together. And I want to talk about what the difference is between a definite integral and an indefinite integral, right? So an indefinite integral is just another name for the antiderivative of a function. Okay, so when we evaluate it, what do we get? We're not going to have limits of integration, right? This is an antiderivative. It doesn't have the limits of integration, just has these symbols, yes? So what does that give us? It gives us an expression, right? It equals to a function. So in other words, an expression with variables in it, right? I'm going to call it with x's, because that's the name of the variable there. Yes, so it's going to be an expression, 5x squared plus 2x minus 3. It gives us a function. right? What type of function? Let's call it f of x. So that what? The derivative of f of x is this little f of x inside. Yes, so it gives us the antiderivative. It gives us a function. It gives us an expression, right? So something with x's and y's. So it gives us the original function again. Now, a definite integral is going to be a value, a number. So the answer comes up to be 5. What else did we get? 15.236, 20, right? So it's a number. Yes, it's not an expression. For now, what does that give us? We are going to have a whole bunch more application. The first application is that it gives us the area under a function, right, between the x equals to a and x equals to b, right, down to the x-axis only. So how do you see that definite integral written? You have to see these limits of integration. You see two numbers there. Now, what do? We still find the antiderivative, yes, but we have to, once we found that antiderivative, plug in the b and plug in the a in this exact order so you can get a positive value, okay? Same thing, where f prime, capital F prime, is this f of x, okay? So it's a number. Now, as I said, there's going to be a whole lot more applications for it. Here is another one. Now, if you remember, an indefinite integral is your antiderivative, right? It takes us backwards. A definite integral gives us the total accumulation. So I'm going to say this, I've said it on the first page too. A definite integral gives us an accumulation in the function values between a and b. Now, which, given the rate of change in that function. Okay? So in other words, if I'm starting with a rate of change, marginal cost. Yes, so let's say this is the marginal cost, yes? And I want what? The integral. So I'm given the marginal cost of producing some items. In other words, what? The rate of change in the cost of producing those items. So I might say every year or every number of item that I'm producing, the cost goes up by $2, right, per item, right, type of thing. So it's a rate of change in dollars, right, per item. Now, what is that going to give me? It's going to give me the total cost of producing between A and B many items. So in other words, what? How much did it cost to produce, let's say that's 100 and that's 200. How much did it cost to produce 200 minus how much did it cost to produce the first 100 items? So it's the cost of producing between item 100 and item 200, right? So what was the cost of that. And here's the problem. Let's just do that right away. Okay, so here it is. Fine, I'm talking about marginal revenue, marginal cost, don't matter. So let's just change it a bit and look at the marginal revenue. So it says, given the marginal revenue function to be this, in other words, this is the rate at which the revenue is changing, measured in dollars per unit, where X is the number of units sold. So how does the revenue change with respect to how many units you are selling? Yes. What we want to do is find the total revenue gained from selling between 100 and 200 units. So that's just what I said. So I am given the derivative, and I want to find the antiderivative. Okay, so, and not just any, but the total. I'm not asking to find a revenue function or an equation for the revenue expression, right? Like I said in the first sections, I said, can you find me a function that describes the total revenue of the first X units sold? No, I want the total revenue gained between these two values. So what I want is a definite integral, a total accumulation in revenue between units, between selling units 100 and 200. So here is that. Okay, how do we find this? We find the antiderivative. Okay, which again, we found it many times by now, between 100 and 200. Okay, I'm going to simplify that a bit, and that's going to be an x cubed only, minus 2x squared plus 5x. Again, take the derivative of all of this, and you're going to come up exactly with these three terms, but now between 100 and 200. So what do? I plug in 200, put that in your calculator, minus, plug in 100. Okay, put that in your calculator, and you're going to come up with a huge number, 6,940,500. So you're going to gain close to $7 million from selling between the 100 and 200 units of whatever it is that you are selling. Okay. All right. So let's try another one. It says, a tree is growing at a rate of, and there's your first clue, the rate. I'm giving you the rate. In other words, if I'm giving you the rate, I'm giving you the derivative. And you also know it's a rate because it's inches per year, right? It's a rate, right? At this fast, a tree is growing. Find the total growth. So it means to go back and find the antiderivative of the tree between the 4th and 9th year after it's been planted, when X is the number of years, right? Since planting. And again, I know that because it's per year, so it's number of years. All right, so all I have to do is simply find the what? Total growth means to find the antiderivative, and I'm giving you the limits of integration from 4 to 9. 2 squared of x dx. Same thing, before I even find this definite integral, what I might want to do is mess with that square root. Okay, so find the antiderivative. And by now, again, maybe we got some practice. 1 more than 1/2 is 3/2 divided by that 3/2 between 4 and 9. I'm going to make it even prettier. To divide by 3/2 means to multiply by 2/3. So 2 times 2/3 is 4/3. You can check up on me if you want, between 4 and 9. Okay, so plug in a 9 minus plug in a 4. Okay, put that in your calculator. You're going to come up with 327 divided by 3 is 936 minus, that's going to be 832 over 3. Okay, put that in your calculator and you're going to come up with 25 1/3 many inches. Okay, total growth. Maybe I should have made this the problem for the child and make that other function the problem for the tree. So you know what I'm going to do next year already. Okay, so this is getting to be a long video, but I promise I have just one more practice question. The more the merrier. Oh, 2 more. Ooh. Okay, fine. We'll just try and put it on the same video. Okay, national debt of a country is growing at a rate of, so again, there is your derivative. Find the total accumulated debt in the next 5 years. So what does it mean in the next 5 years? From now until 5 years from now. Now means what year? Now means year 0, right? So from now, we're starting at, not a year from now, we're starting at time 0, yes? So it's going to be the integral from 0 to 5 of 2e to the 0.05t dt. Don't forget to change it to the name of the variable, right? That's what you're taking the integral with respect to. So that's going to be a 2e to the 0.05t divided by 0.05, right? That's the antiderivative of an e. We talked about this in 5.2. But now we need to plug in the 2 limits of integration. So 2 divided by a 0.05, put that in your calculator and you're going to come up with 40. Okay. 05t, plug in a 0 and plug in a 5. So that's a 40 e to the 0.05 times 5 minus 40 e to the 0.05 times 0. Okay, put that in your calculator. That's going to come up to 51.4 minus, again, remember, e to the 0 equals to 1, and 1 times 40 is 40. So that's going to be 11.4. Not dollars, this is in what? Billions of dollars. All right, well, that makes sense. Okay. In the next 5 years, there'd be a total accumulated debt of $11.4 billion. Okay. And finally, one last quick one. It says a secretary is able to type at, oh, surprise, surprise, rate of. Okay, so again, that means I'm giving you the derivative over and over. Rate of means the derivative. And as you can tell, it's a derivative. It's a rate. It's words per minute, right? So it's a rate. Where X is the number of minutes after she started typing. Find the total amount, or don't have to say total, but it clearly is total amount of words the secretary can type between the 5th and the 10th minute. So that's number of minutes. And again, see how I'm giving you 2 limits of integration from here to there, from here to there, from here to there. And that will tell you, again, that it's a definite integral, right? It's an accumulation. And again, the name of the variable changed to x. I'm going to call it dx. Okay. Find the antiderivative. What's the antiderivative of a 1 over x? That's an ln of x, absolute value of x. Plus, antiderivative of 30 is 30x. plug in a 5 and plug in a 10. Well, in the other order. So it's 20 ln of 10 plus 30 times 10 minus, keep it grouped when you have more than one term so you don't forget, as you've been forgetting with other things, to distribute in that minus. Okay, and I actually don't have an answer for that. Already calculated out. And I'll do that really quick. So it's a 20 times ln of 10 plus 300 minus 20 times ln of 5 and then minus 150 equals 163.9, so about 164 words. Done. All right, done.